Every day I'm physicsing. So this is Unit 6. We're talking about forces in F equals ma. This is practice problem 5.6 here. At this point, we've started to look at some vertical motion problems, and that's what we've got going on here. And it's got a little bit of a twist, taking us back to our prior units on kinematics and moving objects. So in our problem here, we've got an extreme amusement park ride. Accelerates its riders upward from rest to 50 meters per second in 7 seconds. Let's ignore air resistant. What average upward force does the seat exert on a rider who weighs 1120 newtons? So, okay, and we got a hint here. Use a motion sheet calculation to calculate the acceleration, then applies Newton laws. So what's going on? Well, let's see. If we draw a free body diagram of our ride, we've got our rider here. They're being accelerated upward by some force, which this is what we're looking for. And they're being pulled back down because they have a weight, right? And we know weight equals a mass times gravity. And in our case, it's 1120 newtons. We also know that they're going to accelerate, but what rate are they accelerating at? Well, we know they start from rest, so that means their initial velocity is 0. And we know they end up at 50 meters per second, so their final velocity is the 50 meters per second. And if we recall, acceleration is a change in velocity divided by time. It's a final velocity minus an initial velocity divided by the amount of time it takes to do that. So what we can say here, because we know this time, is the acceleration that the rider is experiencing is 50 meters per second minus 0 meters per second, final minus initial, divided by 7 seconds. And that means our acceleration here is just 50 over 7, which is 7.14 meters per second squared. So that's our acceleration, okay? But that's not what we want. What we want is the average upward force. We're looking for F in this problem. Well, because we have a free body diagram that we drew out, because Grandpappy Botzer told us to, we can set positive and negative directions. Let's call up positive and down negative. And if we set up an F equals ma, or the sum of the forces, the net force, equals a mass multiplied by an acceleration, we would get our upward force is F minus, well, the weight here. So I could put W, or I could put mg, or I could put the number 1120, because that is the weight acting down. That equals the mass of our rider multiplied by the acceleration, which was 7.14 meters per second squared, because that just came from over here. Now, looking at this, we have F in this equation, which is nice, but what the heck is the mass? Well, we know what that mass can be, but it's going to take us a little bit of work right here. We know we can solve for mass. mg equals 1120 here, and we know g, that's our gravity here on Earth, we know that to be 9.8 meters per second squared. Some people write this as negative 9.8, but that negative's already been used. That negative was the fact that this arrow was pointing down in the negative direction. So that negative on the negative 9.8 is actually right here. So we don't need to include the negative anymore. It's popping in due to our free body diagram. So all we need to say to find the mass is we can say that since mg equals 1120, the mass is just going to equal 1120 divided by that 9.8. This will give us a positive mass, which mass has to be positive. If you ever come up with a negative mass, let me know, because there's some theories that we can keep wormholes open with them. But we haven't found it and never will. But our mass we have here is 11.4 kilograms here, so 114 kilograms. So we can plug that in for our mass here. So we can just say that the force that we're looking for minus 1120, the weight, equals 114 times 7.14. And at this point, we just need to solve this out. This is a pretty basic math problem. Let's multiply these together. So 114 times 7.14. It's going to give me 813.96. So let's just call it 814. So 814 newtons, F minus 1120. And then we simply just need to add the 1120 over to the other side. That goes away there. and we find that the force will equal whatever 1120 plus 814 is, and we get 1934 newtons. And that's the average force acting up on the person in this problem. So it was some more F equals ma. A little bit of a twist here because we had to go back and do a little bit of kinematics in the beginning to find an acceleration. So that's bringing out the old school stuff. We still had to set up our free body diagram like always and our F equals ma equations. But this time we had to recognize that, hey look, I don't have the mass, but I know the weight, and weight equals mass times gravity. We went and found that mass, plugged it into the problem, and then just solved out from there. So it wasn't bad once we had everything, but drawing those pictures, using what we have, makes our life a little bit easier in these type of problems. So as we go through some more of these vertical stuffs, don't forget about your weight, don't forget about drawing your pictures, your free body diagrams, and make sure you're including all of the forces whenever you're setting up your F equals ma equations. But until next time, this problem is finished. Adios. Take it easy.